Welcome to graph analysis. Now we're talking about largest connected components in a graph, or also short LCC. Largest connected component is really important if we have a graph that has multiple components or subgraphs that are not connected with each other. So in an undirected graph, a connected component is when a node is reachable by other nodes. And if no node in the subgraph is connected to another subgraph. So you have different clusters that are not connected with each other. And the largest connected component is the component containing the most nodes. Which sounds super simple, is super simple. So the LCC size is the count of numbers of nodes within the largest connected component in a given graph. And in a fully connected graph, where all the nodes are connected with each other, the total number of nodes in the graph is also the LCC size. Changes in LCC are really important, especially later on if we look at resilience. So how resilient is a graph to a node failure, that a node is not working anymore. And because with the removing edges or nodes, the LCC might also change. So this is a really great measure to consider resilience in a network. Where I want to show you LCC in size and as an absolute perfect example, I think, is in adolescent romantic and sexual networks. And this graph is in the paper by Behrman and others. And I really want to thank Peter Behrman for the opportunity to use this graph in this open educational resource here. So what you're seeing here is the data of a real American town where they asked high school students about their romantic relationship and attachments they had in a previous time frame. And I highly recommend to read the description of the data. It's definitely one of the best parts in economic writing that you can do, and the description of what is all possible in social activity in this town where this Jefferson High School takes place, and which is pretty much driving your car around and hanging out and underage drinking and dating, and what is all not possible in this town, like going to the movies. And so you have this Midwestern town. You have pretty much all high school students telling you all their romantic attachments they had over a specific time. And what we see here is we have several small components in this network where people dated one or two people. We have like a few connections here in the top right where you have like a small chain. And then on the top left, you have a huge graph. That is a really interesting subgraph. This is the largest connected component of romantic relationships at this Jefferson High. This is a really important aspect as well. Here, the description of the data is to look into the sexual networks and STI transmission possibility and which people are how popular. And for this paper, asking high school students in, as I recall correctly, the early 90s in a Midwestern town, if you look into the data and see the male and female differences, you will be surprised for how openly you also see homosexual relationships for that time. So this is an indication for the data actually being super accurate if students were willing to disclose that to random researchers they met on the street. But it's also a really interesting aspect in this large connected component to see that you have this circle graph of which several branches go off. So it's one of the graphs where if you want to nerd out, you can spend hours and hours on it and you find more and more interesting things. And in order to look into STI transmission, for example, it's really important to consider the time factor. Who dated whom when and in which order. That is something we do not have in this data, but I think it's still a really great opportunity to look into the largest connected components and how they play out in real-life networks.